So I kept a point charge Q here. Now let me pick up 2 points, 1, 2, and say some arbitrary point 3. Now what is the potential at point 1, 2, 3 due to point charge? Potential at point 1, 2, 3 due to point charge should be equal, because this is the circle of radius r. So potential at 1 equal to 2 equal to 3, which is equal to kq by r. Will I agree? No. What is the work done by X-ray agent in moving a point charge from 1 to 2? Work done by an X-ray agent in moving a charge from 1 to 2. So some point charge, some test charge. How much of work it should do? It should be equal to V2 minus V1. And what is the potential at both the points? It is same. 0, no? So now, so one person what will move the charge like this. Next, you will move the charge along this one. There's a path. Next, you will move like this. So in all 3 paths, what is work done by him? Same, it is equal to 0. So therefore, we know that if a work done is independent of path, then what is that field? Conservative or non-conservative? Should be conservative field. So therefore, the field produced by a point charge is a conservative. Like this is what happened. We are going to give a proof for all these things. So here work done. So there's a path A, B, and C. Work done by X-ray agent in moving a charge particle along the path A, along the path B, along path C. It is equal to 0, or moreover, it is equal. So therefore, as work done is independent of path, as work done is independent of path, what is the conclusion we can make it? Work done is independent of path. So therefore, the field is conservative field. Getting the idea? So now similarly, how much of work it should do to move from 1 to 3, also the same thing. So it will be 0. Work done by X-ray agent in moving a charge particle from 1 to 3, or 2 to 3 will be 0. It's independent of path here. Now, instead of that, somewhere I'll pick up. Let me take one more question. Getting the idea, no? So this is about the direct application of what we learned it. Okay, let's take one more example. So there's a point charge Q. This is a point 1. And this is a point 2. It is at a distance R1, R2 from the point charge. Okay, there's a point charge. So now X-ray agent has to move the test charge from 1 to 2. What's the work done by him? We know how the field will be. I wanted to let me give a very good explanation for this. So we know due to point charge, there's a field, no? You see this? There's a point. From here, I wanted to move this one. So how is the path? It's left to him. So what is work done by X-ray agent in moving a charge from 1 to 2? So the formula will be work done by X-ray agent in moving a charge from 1 to 2 should be equal to the charge into V2 minus V1. KQ by R2, KQ by R1. This much of work it should do. How the path? Any path. He can pick up whichever path he likes. So there's a one path. He may go straight. He may take some path like this. He may go and come. So in any path, okay, this much of work he should do. By external agent, ma, this is by external agent. Please try to follow the formula. Work done by external agent. Please, all of you write down these formulas in your notebook because I'll be discussing all the numericals related to this one only. Please, all of you note down first. Huh? Note down first this yellow color and green color highlighted formulas. Write down first, you write down, then I'll continue.
Sir, one doubt, sir.
Oh, yeah.
Sir, in work done by electric force in moving a charge from 1 to 2 equals to minus delta U2, you wrote minus of U2 minus U1, no, sir? There it is U2 is minus W, so it should become minus Q into V2, no, sir?
U2 due to positive charge, what is the potential for Q into V2? No. Why again you are changing the definitions? Huh? Positive charge, I took it, no?
Yes.
See, these are definitions. Don't question them. Finish or accept it. Huh?
Yes, sir.
All of you write down the yellow colors and green color. First you write down, because again you'll be asking so many things related to these questions only. These fundamental formulas are there. So if you can, don't take it in wrong way, that one. That's why I'm asking you to first write down. Then I'll proceed. First you write down. Okay, let me proceed. Okay, fine. So here also, what is the thing? So whatever path, which path? Since it's a field produced by point charge, no? So definitely, and electrostatic field is a conservative field. So therefore, it's independent of path here. So the same answer will come. Either you move from, either you move like this. Means you are, I'm X-agent. I'll be holding a charge Q. This charge Q, what when I'll move it slowly along this path. Then I'll come like this. Then I'll come this. I'll get the same work done. I have to do same amount of work. Getting the idea? So what is the meaning of this? What is this one? Work done. Work done by action agent in moving a charge Q from point 1 Okay, there's a primary discussion what we are making it. So since the field is conservative, so I need not to bother know how it is moved. I need not to bother. Do I know potential at these points 1 and 2? I'll substitute. I'll get the answer. And is independent of charge. Okay, we'll write it. And is independent of path from point 1 and is, I'm concluding everything in the given data independent of path. Okay, you can take several examples of this kind. So let's do one thing. Let's take a diet application. See, I'll